Everyone. We are Group 2 and we are here on presentations on descriptive and predictive analysis of flight price dataset. And moving ahead, so these are the contents. The contents are data import and explorations. We did some data pre-processing and EDA with some business insights and model building and multiple linear regression, the model we used, and the evaluation of the model. And we also use the most influencing factors in the content as well as the model accuracy assessment. In data import and explorations, this project was, we did it to predict flight prices using machine learning. It is used for the business as well as customers to find the best booking time. So while we import the data from Kaggle, we have also included the source and the key features. The dependent variables are flight, source city, departure time, stops, arrival time, and this destination city. And the data types we used, it's a mixture of objects, like there were some numerical objects, numerical data, as well as some string values. And there were some also missing values, and we just calculated in percentage, like 2.97% in durations, and in price, it was 1.99%. And the data set shape was, it was around 300,000 153 columns with 10 features, and we just preview some data by fetching the rows. So moving ahead, we first pre-process the data. After we downloaded it from the Kaggle, we just move ahead into the processing of the data. So first, we just handle the missing values. In missing values, we use the median values for price and duration, as data was not was skewed distributions, and min does not provide the values, as it does not contain the outliers. It doesn't mix the outliers. And also in data cleaning, we just duplicate the rows and also avoid bias. And while detecting the outliers, we just use box plot or graph that is used to show the outliers in a normal range of data and IQR method. And in the feature engineering, we just label the data. We just encoded it, the categorical value into numerical, like airline 1 with 0, airline 2, and with 1. That's how we do it. So moving ahead, these are the research questions which my friend is gonna explain.
Hi, thank you. So we basically, after like doing the pre-processing and like refining data, we then jumped into like coining the research questions. And we coined like 4 questions. The 4 were like, does the time gap between booking and departure affect ticket price or not? And then does the price of transits affect the ticket cost or not? And which feature influence ticket price most strongly? We have also like done the elaborate analysis on all these questions. And the last one, how can these insights support a travel booking platform in improving customer experience and revenue? So moving ahead to EDA, after these research questions, we coined that ticket price peak 2 days before flight. So this means, like as you can see in the graph as well, in the right before like 2 days, ticket price was peaked with the high. And then another thing we identified was late night arrivals have lower prices. So every price that have like arriving time at late had the like lower prices. And we also like calculated the business class tickets versus economy class tickets, and we found that business class tickets were really high. And another one was one-stop flights, so high price distribution. So the flights which have only one stop tend to have higher price distribution. So moving ahead, after like doing this, after doing this EDA, we moved to like building the model, and we choose the multiple linear regression model. And to build the model, what we do was we define the dependent and independent variable, and our dependent variable is price, and all other independent variables were encoded so that it was later processed for the train and test. And so we split the data into training data set with 80 to 20% ratios with a random seed of 1, up for reproducibility. After splitting, we applied some target encoding to flight feature. So basically, flight had many attributes. So we use category encoders library so that it can handle all those values. And after that, we build the regression model. And after building it, we feed the model into training data set. So after training data set, my friend Sanjay will cover like how it went.
Okay, so after implementing our machine learning model, that is multiple linear regressions, we came up with the following evaluation metrics. We got the R square value is 0.883, which is actually the 88%. What it generally explained is 88% variability is explained by our independent variables. And here we got the YOME, which is the mean absolute error is 68.88%, which actually represents the prediction price deviations is actually by about 68 in amount. And we got the RMSE is high, that is 7683, and we will verify if we verify all this value by applying the another model such as a ridge regression and lasso regression, and we apply the k-fold cross validation methods, and we will also evaluate this all of the metrics from those model as well. From the linear regression model, we got to know that top 3 features that influences the price most are class, stops, and arrival times. We order the coefficient value in descending orders and pick the top 3 features, and we got to know that these are the features that influences the price most. And so we apply the lasso regression and ridge regression and k-fold cross validation as well. Here we got the R square value is almost same for all of the 3. And but here YOME, we got the YOME and RMSE is high. So here YOME value is 4,700 around, but our price range is between the lowest price for our data set is around 1100 and the highest was 120,000. So due to the high range of price, this EMA is I think quite acceptable. Next slide. Yeah, thank you.
Thank you, everyone.
Thank you.